Okay, so far we've done quite a bit of integration, the mechanics of it, how to integrate. But I think it would be a very fair question to ask now, what's it good for? Why am I integrating this stuff to begin with? Let's take a look at this function. This is a parabola of some sort. Now you can see that I've put a couple of marks on here. There's a point here, 452, and there's a point here, 8200. Now, what is integration good for? One thing you can use integration for is finding the area under a curve. By area under a curve, I mean the area between the curve and the x-axis. So this yellow line here, the area inside that shape, we can find that by doing some integration. Just briefly before we move on to actually how to do that, you can make a bit of an estimate. You could say that, okay, approximately it's a rectangle by 200 by 4. 200 by 4 is 800. Now, that means the area of that entire rectangle is 800. I could approximate the area under that curve by cutting that in half. So if 2 times 4 is 800, it looks like the area under that curve is going to be a little over 400. That's a pretty good starting point. There's also other ways that we can do it. One is called the rectangle method. Basically, you draw a bunch of rectangles. Rectangle, 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 rectangle. Find the area of each of those rectangles. Obviously, you need to know this point, this point, this point, so you know the height of each rectangle. You can add up the areas of each individual rectangle, and that will give you an estimate. In this case, it will give you an underestimate, because you can see the rectangles cut out this bit, this bit, this bit, this bit. And then you can come to some sort of approximation for the area under that curve. You can also use a slightly different rectangle method. Okay, so this is just a slightly varied rectangle method. You can see that this rectangle method this time is going to overestimate the area under that curve. It's overestimating this point, this point, this point, this point. These are little extras. If you use both methods and then average them, you might come really, really close to that area under the curve. Also, if you drew more rectangles instead of using just 4 like I have, if you drew 8 or 10 or 16 or 32 or 100, you get very, very close because those pieces will be smaller and smaller. In the next video, we'll look at integration and how you can come up with an exact answer for that.